Hi ladies and gentlemen, I hope everyone is doing well today. Today we're taking a look at more Lewis structures found in your Unit 7 note packet. Step 1, or question 1, starts off with just drawing normal Lewis structures. We just practiced drawing a bunch in class, so these are the same 5 steps that you will follow found on page 4. Next, in this problem, I'll tell you you'll see a single bond, a double bond, and a triple bond in those problems. Try to think about what they represent. Keep in mind that single means 1, double 2, triple 3. What obviously is going to represent the lines, so think about what the lines represent, and that will help you answer this question. Wait to fill these in on your vocab sheet because we are going to go over this single, double, and triple on the do now. Still come up with your definitions though. I'm going to expect people to share. Question 3. So question 3, which one do you think is harder to break, a single, double, or triple bond? So if you remember, bonds happen because of sharing of electrons. So I think about this like glue. The more glue you have, the stickier, the more held together something is going to be. So think about that with single, double, and triple bond. Which one has the most electrons that are being shared? Next, we come down to bond length and bond energy. So these are two definitions that I forgot to add to your vocab sheet. So you should have a little bit of room under Vesper theory to be able to include these definitions. Remember, bond length is just the distance between two bonding atoms, and then bonding energy is the amount of energy needed to remove or destroy the bond. One thing that you guys you need to know this table. You don't need to memorize these numbers, but you will need to know the trend. You will need to know that a single bond is the longest, and then as you go down to a triple bond, it gets shorter. You will need to know that single bonds start with the lowest energy, and then as you go down to a triple bond, it has higher energy. So next we are moving on to questions 4, 5, and 6. Questions 4, 5, and 6 use the table that we just talked about. So look at the data, use the data to answer the questions. That's 4, 5, and 6. And then question 7. Question 7 right here, I give you a structure of benzene. You're never going to have to be able to draw a structure like this, so don't worry. What you do need to be able to do is label the structure. So if you were to look at the carbon single bonds and the carbon double bonds, what would be the length for part A, and then part B is asking us what would be the bond energy. So on this picture, just draw some arrows and label the bond length and bond energies. Again, that is going to come from this table right here. So next we come down to some information on resonance structures. So in all molecules, so if you looked at this benzene molecule right here, we have double bonds in various positions. What you need to think about when we think about resonance structure is why are the double bonds here, here, and here, and not in where the single bonds are? They could potentially be here, here, and here. And would the structure change? The answer to that question is no. So when we draw a benzene molecule, we need to take into account its resonance structure. So resonance structures are the same structures with different positions of the doubles or the triple bonds. The structure does not change. The only thing that changes is the position. The reason why this happens is because the length and the energy is the same between all of the carbons. So when they form, the bonds just form randomly. We will not know in this example of benzene where the bonds are until it is tested experimentally. So then when we draw resonance structures look like this on the next page. So simply a resonance structure is just redrawing the same molecule with the double bonds in different positions. So normally they start, if we were to label these, we could label them 1, 2, 3, 4, 5, and 6. If you looked at the next example, the position of the bonds just changed. So now 1 is a single bond, 3 is a single bond, and 5 are single bonds. 2, 4, and 6 become double bonds. So all you have to do is just swap the bonds. So next, when you are thinking about question 8. Question 8a starts off by asking you to draw a nitrate ion. So again, you are going to use the 5 steps on page 4 that we use to draw all Lewis structures, and then you're going to look at the structure. When you look at that structure, you have to ask yourself, Can that double bond be in multiple places? And if so, you just need to draw you need to just draw it, and you include a double-sided arrow. It is important to note to use a double-sided arrow just like this, because arrows of just that are just like single lines like that, they mean something different. When you draw your resonance structures, you do need to make sure to have a double-sided arrow. And then lastly, when you are thinking about B, just think about why there's three structures instead of two. So just ask yourself how many places can the double bond be, and that will help you answer 8B. Like always, if you have any questions, please make sure to circle it. Please make sure to write down your questions. That way when you come to class, you don't have to try to remember what to ask me. Also, make sure you get your definitions down on the front. Don't include single, double, and triple bond yet. We are going to talk about those in the do now, and that way you can get the exact definition. I'll see everybody in class.